Welcome back. So in the previous video, I talked about certain transducers which take electrical energy and converting them into sound energy, right? Electrical signals into sound energy. So today, what we're going to be talking about, we are going to take electrical signals and we're going to be converting them into mechanical energy. Okay, so the first one that we're going to be talking about is called DC motors. I'm sure you have heard of motors before, DC motors. So a motor is an output transducer that converts electrical energy into mechanical energy. Okay, so you have definitely seen these before. In your ALP class, you have used motors before to run your robots. So this should not be anything foreign to you. And the type of DC motors that we have in the lab is this kind. Okay, so it has your terminal leads here, and this is your spindle, which rotates once it has the electrical signal coming in here. Okay, learn how to draw the symbol of a motor. So this is how basically a structure of a motor is. Okay, so okay, basically when I have the current going in here, the current comes through here, and out here. Now what happens is that when you put a pair of magnets, a north-south magnet, surrounding these coils of wire that is carrying your electrical energy, a magnetic field is produced. Okay, a magnetic field is produced in this coil of energy, and this magnetic field will interact with the magnetic field of the magnet. And when the two magnetic field interacts, what happens is that the shaft here, this is the shaft that I'm talking about, the spindle here, it starts to rotate. Okay, now how and why it does that, you will learn this in physics in your Sec 4, but it's got something to do with Fleming's left-hand rule. If you want to learn more about it, you can go and check it out. Okay, this is Fleming's left-hand rule. All right, Manchester Football Club. Okay, motion, field, current. Go check it out. Okay, so in this course, you'll be using low voltage DC. All right, so typically you probably have to consider DC motors. Our DC motor runs at about 5 volts, so think about that when you want to use DC motors. And one thing is that we want to add in a reverse bias diode as shown here. Okay, now this diode we call a flyback diode. So why we put this flyback diode is to prevent a negative voltage spike every time I turn off the motor. Okay, so this negative voltage spike, if I don't have the flyback diode, will damage the transistor. All right. You'll be asking, so what in the world is a transistor? Don't worry, we'll learn about it in the next chapter. But essentially what we do not want is this negative spike to damage your transistor. So to do that, we put in a flyback diode here. All right. So just take note of it. If you're not quite sure how adding a transistor here, a diode here protects the transistor, it's not really in our syllabus. Just know that we need to put a flyback diode. And take note of this also when you're building your circuits involving the motor. Okay? Okay, the next one that converts electrical signal into mechanical motion is what we call a relay. Okay, a relay is a special type of switch. So it's a switch. And usually for switches, you would be thinking about a mechanical switch, maybe a single pole, single throw switch like this, or a push to make switch like this. Yeah, so those are your typical switches, but there are also electrical switches that we can use, and one of which is a relay. So again, it's going to make use of electromagnetism. What happens here is that when you have a small current going through here, when you have a small current going through here, it magnetizes this iron core. And when this iron core is magnetized, it is going to attract this armature. And when this armature is attracted in, if you can picture this hand as an armature, and as the iron armature is attracted, you'll notice that due to the pivot here is going to pivot this part upwards. And when this part pushes the insulator upwards, the two contacts are going to touch. Okay, so what happens, yep, like this, as you can see it, what happens is that I'm taking a small current here and I'm going to turn on or off another contact. Yeah, so when I have a small current coming through here, a small current coming through here, if you remember, due to the electromagnetic forces, it is going to attract this fella to close the switch. Okay, so let's see, this is what it looks like. The ones that we have are not see-through. Yeah, the ones that we have are not see-through. So we need to consider, when we're using a relay, the voltage and the current ratings. Okay, so when I see a 24 volt printed on the label, 24 volts here, it indicates that this is the maximum DC voltage. Do not apply anything more than that. You might damage the relay. Okay, same thing for the current. So when you see 3 amperes, do not put in more than 3 amperes in there. Typically, of switches, relays come in many varieties. You have Singapore single throw, Singapore double throw. The ones that we have are a double pole, okay, a double pole, double throw type, okay? And the ones that we have NO and NC both in that one double throw, double pole, double throw. NO stands for normally open. Okay, so that means if you don't do anything, it's going to be a open switch. If you don't do anything, it's going to be an open switch. Yeah. When, okay, the opposite will happen, normally close. For normally close, it is normally closed up. So when you put a current through, then it will open up. Okay, over here, it is normally open. When you put a current through, then the switch would close. Okay, so the relay that we have in our lab has both a normally open and a normally close. Okay, Ken? So this is your normally close and this is your normally open. And as I said, because it is a double pole, what it has is that you can actually have two circuits, circuit 1, circuit 2 going on at the same time. Don't worry if you're confused. I'll probably produce another video specifically on the relay that we do have. Okay. Okay, so likewise, you'll notice that there's something over here. We also have a flyback diode. It's also to prevent a voltage spike, and this time is to prevent damaging the 5-volt circuit. Okay, we do not want the voltage to damage this fellow over here, the negative voltage spike. Okay, Ken? So to summarize, a relay uses a small current. This small current will activate the electromagnet, and this electromagnet will attract the armature of some sort to close. This is a normally open, and when this fella closes, I have another second circuit. that will work. And usually, this usually is a larger signal or larger voltage current circuit compared to your activating turning on, turning off current. Okay, so I'm going to stop here. The next part is your review question. Please make sure you do it. Pause the video here, do it.